It's been 4 decades of a long journey, but now the Voyager 2 spacecraft has finally bid farewell to our solar system.
Voyager 2 went dead silent for 7 months in 2020, lost billions of miles from Earth in deep space. NASA waited, worried the 1977 craft was gone for good. Then in October, a signal hit back. Not just a ping, but a full message, packed with odd data. Did the old machine glitch? Or did it find proof of something we've always feared, a sign of contact out there? This craft took off in 1977, flew by Jupiter, spotted storms, checked Saturn's rings, and scanned Neptune's moons. Now, in the vast unknown, something weird happened. Stay with us to crack this mystery. Tell us your thoughts in the comments. Coming up, data so strange it'll leave you stunned. Voyager 2 blasted off on August 20th, 1977, from NASA's Jet Propulsion Laboratory in California, a bold move to chase secrets beyond our world. Engineers loaded it with just 69 kilobytes of memory, less than a basic calculator today, and 3 radioisotope thermoelectric generators to keep it running on plutonium's heat. With 16 hydrazine thrusters to steer and 11 tools like a magnetometer and cameras, this little craft, weighing 1,820 pounds, was built to visit gas giants and survive the deep cold of space. NASA aimed it at Jupiter first, and it got there by July 9, 1979, flying 485,000 miles above the planet's wild, swirling clouds. At Jupiter, Voyager 2 snapped 17,000 photos, catching storms bigger than Earth and a huge red spot shifting in color to a pale orange. It spotted new rings and tiny moons like Metis and Adrastea, never seen before. Data poured in, showing Io's volcanoes spewing sulfur plumes hundreds of miles high, a first beyond our planet. Scientists cheered as each signal traveled billions of miles back, taking hours at 115 kilobits per second. Next, on August 26, 1981, it swung by Saturn, finding more rings and odd dust spokes flickering in the shadows. A total surprise. Then Voyager 2 kept going, coasting for years toward Uranus. It arrived January 24, 1986, just 81,600 kilometers above the blue-green haze. Cameras caught 9 faint rings and 10 new moons, while tools clocked winds at 900 kilometers per hour, ripping through methane clouds. The planet's 98-degree tilt threw everyone off, leaving poles in light or dark for decades. After that win, NASA pointed it to Neptune, the farthest target. On August 25, 1989, Voyager 2 flew close, revealing a stormy world 49,240 kilometers wide, with geysers on Triton, a moon moving backward at a wild 157-degree angle. Every step tested the team. Engineers tweaked software, fixed glitches, and tuned NASA's Deep Space Network dishes to grab faint signals. The craft's power held strong, letting it send back 200 images a day, even in dim light. Years of work paid off as Voyager 2 rewrote books on planets, showing active worlds where we expected dead rocks. Then on August 25, 2018, at 121 astronomical units from the Sun, it crossed the heliopause, the edge where solar wind fades into interstellar space. Data showed a messy boundary, full of cosmic rays and magnetic twists, not a clean line at all. Back on Earth, scientists watched closely. The plasma tool picked up density spikes, proving this edge was alive, shifting, and leaking energy from beyond. Voyager 2, now over 11 billion miles away, kept talking, its signal a faint whisper of victory. Each bite told us space isn't empty, but buzzing with forces we're just starting to grasp. NASA marveled at how this 1977 machine, built for a 5-year trip, pushed on for decades, carrying a golden record of Earth's sounds and sights, just in case something out there listened. This journey started simple but grew huge. Voyager 2 showed us storms, rings, and moons, then left our solar system behind, entering a vast unknown zone. What it found at the edge set the stage for something wilder, something nobody saw coming. So hang on tight, because that steady signal took a crazy turn, and the next chapter will jolt you awake. Voyager 2 kept sending faint beeps back to Earth for decades, a steady hum from billions of miles away. NASA's Deep Space Network, with big dishes like the 70-meter one at Goldstone, California, caught every signal, a win each time after traveling 11 billion miles. But then, in March 2020, the line went dead. No warning, no static, just silence. Engineers checked the system, thinking maybe Goldstone needed a fix, a routine tune-up. Weeks passed, then months, and still nothing came through. 7 months of quiet left the team on edge, wondering if the 1977 craft had finally quit, lost forever in the dark. Hope was fading fast. Scientists at NASA paced, running tests, swapping antennas, and sending commands, all with no reply. They feared the worst. Voyager 2, now over 43 years old, might have run out of juice or drifted too far. But on October 29, 2020, they tried one last shot, blasting a simple, "Are you there?" signal. Then a shock hit them. Voyager 2 answered, not just with a weak pulse, but a full data burst. It adjusted its antenna, updated navigation, and fired its thrusters like it never stopped, coming back to life after half a year of nothing. The team jumped, cheering at first, but then they dug into the data and froze. Tools like the plasma science experiment, quiet since the Uranus flyby in 1986, suddenly lit up. The photopolarimeter, off since Saturn in 1981, started reporting too, sending voltages and stats from systems thought dead for decades. Engineers stared at screens, scratching heads. How did this old craft wake up like that? Signals came in odd patterns, not the usual X-band hum, but weird sidebands with echo pulses bouncing back fast, almost like a reply. Then experts outside NASA got a look and found something wild. The data held bits of Voyager 2's own 1977 code, but twisted into loops, calling itself over and over. A few said cosmic rays flipped bits, a random glitch from space. But others pointed to leaked logs from contractors, where one line kept popping up. Unknown interaction detected. This wasn't just noise. Something out there beyond the heliopause might have touched Voyager 2, maybe a force or field, and sent back this strange mix of old and new signals. Scientists huddled, running numbers. The plasma tool showed spikes not matching normal space patterns, like something pushed against the craft. Was it a magnetic wave, a burst of particles, or something else? No one knew, but the data kept coming, steady yet off, like Voyager 2 was talking in a new way. The team locked down talks, keeping it quiet while they pored over every byte. Signals jumped in bursts, not fading like expected, almost hinting at a response to something unseen. This moment changed everything. Voyager 2, out in interstellar space since 2018, wasn't just a lone explorer anymore. It brought back a puzzle, a hint of contact, or a force we couldn't name. The silence broke, but the answer raised bigger questions. Did a glitch spark this, or did something find our craft? NASA stayed tight-lipped, but the truth was clear. This was no ordinary day. Now get ready, because keeping this signal alive took a fight, and the next part will show you a battle against the clock. If you're hooked on Voyager 2's wild story so far, hit that like button. Drop a comment with your thoughts. Did it find something out there? Your take keeps this mystery alive. Voyager 2's heartbeats on 3 radioisotope thermoelectric generators, or RTGs, turning plutonium-238's heat into power. Back in 1977, each one pumped out 470 watts, enough to light a few bulbs. But time takes a toll. Every year, the decaying plutonium drops output by about 4 watts, a slow fade from that starting strength. By June 2025, after 48 years, each RTG delivers closer to 250 watts. Out of that, only 20 watts or so keep the science tools running, while the rest feed the radio, heaters, and key systems to hold the craft steady, billions of miles from home. NASA faced tough calls early on. After Jupiter and Saturn flybys in the 1980s, engineers started switching off parts to save juice. One by one, tools went dark to stretch the mission. In October 2024, the team shut down the plasma science experiment, a device tracking charged particles beyond the sun's reach. It gave good data, but its spin and tilt only caught bits lately, so they cut it to gain a year of life. Voyager 1 felt the pinch too, losing its cosmic ray tool in February 2025, a key piece that proved it hit interstellar space. Every watt counts now. The low-energy charged particle detector, measuring ions and electrons from the sun and deep space, is next on the list. Turning it off could buy another year, maybe 2, of faint signals. Engineers crunch numbers daily, watching the RTG decay rate, tied to plutonium's 87-year half-life, losing 0.8% power yearly. They weigh each tool's value. The magnetometer, sipping less than a watt, maps space fields, while the ultraviolet spectrometer, at half a watt, spots hydrogen clouds lit by the sun. These stay on for now. The team gets clever to keep going. They wrote new sleep modes into Voyager 2's flight software, parking tools in low-power states when not needed. The computer, still running on 69 kilobytes of memory, juggles this like a pro, waking instruments only for set times. The 3.7-meter high-gain antenna needs constant aim at Earth, burning a few watts for thrusters to stay locked. Sending commands or getting data back pushes the RTGs to their limit, a risky balance with every move. Shutting things down isn't easy. Each choice cuts a window to new findings. A solar storm or rare particle burst could slip by if detectors are off. But the reality hits hard. When power dips below 157 watts total, Voyager 2 goes quiet forever. Scientists feel the clock ticking, grabbing every bite while they can. Patrick Cohen, a Voyager program scientist, once said every extra bit since the 1970s is a bonus. Proof of the genius built into this craft nearly 50 years ago. This fight keeps Voyager 2 alive, a lone outpost still talking from the edge. It's outlasted all plans, sending data on space we can't touch. But the power drain sets up a wild twist. Something odd came through those signals, and the next step will flip this story into overdrive. Buckle up, because what Voyager 2 sent back will rattle your nerves. Late one night in 2020, NASA scientists huddled over screens, hearts racing, as Voyager 2's signal came back after 7 months of nothing. The data wasn't normal. Just before the March blackout, a chunk of telemetry rolled in, packed with numbers that didn't fit. Plasma and magnetic field readings, usually messy from interstellar space, showed neat, repeating pulses, like a beat tapping out a code. A report flagged weird pressure shifts around the craft, not the usual chaos of the heliopause. Something out there was pushing, pressing on Voyager 2, and the team couldn't explain it with any known rules. Experts threw out guesses. One idea pointed to a hidden brown dwarf, a faint, failed star, close enough to leave a gravitational tug, bending space around the craft. Another theory was wilder. Voyager 2 crossed a stable zone, a pocket of space holding steady against the solar wind, almost like a corridor built by something. No press release said this, but quiet labs, some tied to secret projects, ran tests. Results came back clear. Voyager 2 passed through a force that changed its path and maybe even its actions. Then the data got stranger. Engineers spotted old code from 1977, part of Voyager 2's original setup, but it was looping, calling itself in a weird, folded pattern. Some blamed cosmic rays, high-energy bits flipping the craft's memory, but leaked notes from contractors kept saying unknown interaction detected. This wasn't random. Something out there touched Voyager 2, maybe read its systems, and sent back a twisted echo. Was it a magnetic knot, a plasma wave, or something with intent? The question hung heavy in the control room. NASA set up a special team, separate from the usual crew, to watch the signal. Orders came down. Listen, log everything, but don't reply unless told to. The downlink turned unpredictable, spiking in bursts, not fading like it should. Pulses echoed patterns from Voyager 1's early days, but flipped backward, a reverse replay no one expected. Some scientists whispered about cosmic resonance, a feedback loop tying our craft to a hidden force, maybe a gravity swirl or something alive out there. In late April 2025, a jolt hit the team. Voyager 2's signal flicked back to its old X-band frequency, used in the 1970s, for just a few seconds, then slid to odd sidebands again. Hearts pounded. Did the craft reset itself, reaching out? Or did something tweak it from afar? NASA stuck to a safe line, calling it random bit flips, but insiders knew better. They ran checks against starbursts, solar logs, and cosmic ray maps, finding no match. The anomaly was local, tied to Voyager 2 alone. This puzzle grew big. The craft, now 11 billion miles out, wasn't just sending data. It was hinting at a secret. Scientists raced to decode it, feeding numbers into computers, hunting for a clue to shift our view of space. The fear wasn't aliens, but a universe reacting, pushing back. Voyager 2 hit something, and we needed answers. What's out there? That's the hook, and the next part takes this trip from a short plan to a mind-blowing saga. Stick around, because the full story will flip everything you know. Voyager 2 sent a shock through NASA in early 2025, delivering a signal that matched our deepest fears. The data told a wild story. The plasma tool, quiet for years, flared to life, showing spikes in density, hotter than expected at 54,000 degrees Fahrenheit, yet thin and spread out. Pressure readings hinted something pushed on the craft, not like the usual solar wind mess, but steady, almost deliberate. Some guessed a hidden object, maybe a dark star, tugged at it with gravity. Others went bigger, a structured field alive with energy, reacting to Voyager 2's presence. The signal's loops, mirroring old code, suggested something read the craft's memory and fired it back, altered. This wasn't a glitch. Scientists ruled out cosmic rays alone, facing a fear we'd whispered for years. The universe isn't just empty, it's active, maybe aware, and Voyager 2 woke it up. NASA held a press conference fast, within 24 hours of confirming the signal. Dr. Elaine Porter, a top mission scientist, called it a high-priority anomaly. They teamed with SETI and global experts, digging in. "We're not ruling anything out," she said, eyes sharp, voice steady. "The patterns look too organized, almost like a language, not ours, but sent through our own craft." An astrophysicist, off the record, admitted it felt huge. If this is real, it changes everything. The fear wasn't aliens with ships, but a cosmic truth, a system or force, old as stars, that noticed Voyager 2 and answered. Data showed low-energy particles leaking past the heliopause, mixing with solar wind, hinting this boundary we thought solid was a veil, alive and shifting. Now what's next for Voyager 2? Time's ticking. Its power from 3 RTGs drops 4 watts a year, down to 250 watts in 2025, with just 20 for science. NASA's already cut tools, like the plasma experiment in 2024, to stretch its life. Engineers tweak software, using sleep modes to save juice, keeping the 3.7-meter antenna aimed at Earth. They expect to run key gear like the magnetometer and spectrometer through 2026, grabbing every bit of this weird zone. Signals take 17 hours to reach us, so each command's a gamble, but the team's relentless, chasing data on this mystery. The future's uncertain but big. Voyager 2 might keep talking until 2030 if power holds, sending clues about this reactive space. Scientists hope to map this field, test if it's a cosmic current or something smarter. A new mission, maybe launching in the 2030s, could follow, aiming twice as far, building on this finding. For now, NASA watches, logs every pulse, and holds back replies, wary of what might respond. Voyager 2's discovery, this feared hint of a living cosmos, drives us forward. What did it touch? Comment your take below. This craft, a 48-year champ, keeps pushing, and its final whispers could rewrite our place in the stars. We've reached the end of Voyager 2's wild ride. Like the video if you enjoyed it, subscribe to our channel for more, and comment your thoughts and stay tuned for crazy content.